Okay, today we're going to discuss dot plots. Dot plots are graphical representations of statistical data. In other words, we're going to create a picture or a graph of a numerical list. To start creating a dot plot, you need a number line, and the range of your number line is going to completely depend on the data you're given. If you're trying to graph test scores that could range from 0 to 100, you need a number line that ranges from 0 to 100. In our case, we're going to get our data from a 12-sided, let's call it a random number generator, so I only need a range from 1 to 12. And your dot plot's going to be a lot easier to read if you'll make sure to space those numbers out evenly. So to get our information today, we're going to let the number cube, or I shouldn't call it a cube, our random number generator create our data. And for every number that occurs, we're going to place one dot above that number on our number line. So let's start. Our first number is 1, so I'm going to put a dot above the 1. Then we have an 11. Then we have a 10. Then we have a 5. We're going to put a fair amount of values on here. We won't take too long. Then we have a 6. Now I have a 12. Oh, I went off the page. Then we have a 12. Now I have another 10. When we have values that are repeated, we're actually going to stack the dots above the value. So I can see that 10 has occurred exactly twice so far. Then I have another 6. Again, I'm going to stack the dots. And now I have yet another 10. And that's probably enough for now. We can see that I've had 1, 1, none of values for 2, 3, and 4. I don't have any 7s, 8s, or 9s, but I've had more 10s than any other number, right? So for instance, we'd have a mode of 10. So looking at an actual dot plot, we asked 30 students how many text messages they send per minute. And you can see the results here. We didn't have anyone that told us they sent more than 12 per minute. And we didn't have anybody who sent 1 or 2 or 10 or 11 messages per minute. And you can count each dot to find out how many times each number occurred. So this dot plot can actually help us find all of our measures of center and spread, plus give us a lot of other valuable information along the way. For instance, in this dot plot, I can easily find the mode as being 6, since it occurred more times than any other value. We can also see that we might have a possible outlier over at 12. Sometimes you'll be asked to create a frequency table from a dot plot. And sometimes vice versa. Sometimes you'll be given a frequency table and asked to create a dot plot from that information. In a frequency table, it lists all the values that you've been given, and in the second column, how many times that value occurred. So you can see that there were 9 dots above the 6, and 7 dots above the 5, and so on. Sometimes in frequency tables, you'll see hash marks instead of numbers, and that's okay. They're the same thing, of course. Given a dot plot or given a frequency table, I can still find all the information I was used to finding before. For instance, if I was asked to find the mean. To find the mean, I know that I have to add 1 3, 2 4s, 7 5s, 9 6s, 5 7s, 4 8s, 1 9, and 1 12. And then I divide it by the 30 numbers in my list. And I'd get a mean of 6.2. The median I can count from each end, or I can know that because I have 30 values in my list, my median is going to occur between the 15th and 16th values. So between 6 and 6, their average is still 6. So of course my median is 6. Graphing those values on my dot plot, you can see why a dot plot might be able to give me that information ahead of time. I can obviously find the mode, and my median is exactly in the center of my graph. The mean with the outlier included is just a little to the right. Because means are so heavily influenced by outliers, an outlier is going to drag my mean closer to where the outlier actually is. If I had recorded the mean or found the mean without the outlier, without including the 12, I would have had a mean of 6.07, which basically makes my mean, median, and mode exactly the same value. There are times when that will happen. One way that dot plots are used is to compare two groups of information. For instance, we have two dot plots here that show the number of junk emails that were received by Marcus and Anders over the past 20 days. And comparing the two graphs, you can see who received more junk emails overall. And of course that would be Marcus, since more of his dots are on higher values than Anders were. We can see who has the higher mean even without calculating. Since more of Marcus's dots were on higher values, he's going to have the higher mean. We can find the mode of each graph. We can see that Anders' mode is 5 and Marcus's mode is 7. And we can find the median of each graph. And again, Anders' median is going to be 5 and Marcus's median is going to be 7. And we can find those between the 10th and 11th values since there's 20 dots on our graph. We also had two classes that took exactly the same test, and we can compare those two classes worth of test scores. If you're asked to find which class scored higher overall, it should be really easy to tell that Mr. Sampson's class scored higher. Which class had only one student that scored a 68? That would be Mr. Logan's class, right? 168 in Mr. Logan's, 3 students who scored 68 in Mr. Sampson's. What's the mode of each class? Mr. Sampson's mode was 67. Mr. Logan's class had a mode of 65. And which class had more students that scored 64? They both had 3 students who scored 64, so neither one had more. All right, now I'm going to give you a chance to try to find these values on a dot plot. Here's your dot plot. I'd like you to find the outlier, the mean with the outlier and the mean without the outlier, the mode, and the median for this graph. Go ahead and pause the video, give yourself some time to find these values, and then restart the video when you're done. Let's see how you did. The outlier is here at 14. The mean with the outlier is 29.88 or 29.9. Without the outlier, the mean was 30.36 or 30.4. The mode is 30 and so is the median. If you got all of these right, you're ready to move on. Otherwise, remember you can rewind and go back and look at examples again. For now, however, I'm going to wish you a great day, and I'll see you next time.